Okay, in the last video we derived this relation like the work done on in ideal gas or the work done by the piston on the gas, which is equal to minus V1 or Vi to Vf P into V, where P is the pressure, and we know that pressure is basically the force per unit area. So it means that this pressure is basically a force. Basically we call it pressure force. Now our next task is to whether this pressure is either conservative or non-conservative, or this pressure force is conservative or non-conservative. Now we have to prove whether this pressure is conservative or non-conservative. Now what is a conservative force? Now if the work done is independent of the path followed, then the force is said to be conservative. Otherwise it is non-conservative. What it means? It means that let's suppose we are moving a body from here to this point. So if the force is moving this particle, if we are applying a force on this particle and moving it from this point to this point. So if the force is bringing this particle either in this way or in this way, let's suppose this is path 1 and this is path 2, such that the work done along this path 1 is W1 and the work done is along this path 2 is W2. If the work done along path 1 is equal to the work done along path 2, either you bring the particles on this path or in this path, in both these two paths we get the same work done, then the force applied here is said to be conservative. Otherwise it is non-conservative. Another word we can also define it as like this: the force is said to be conservative if the work done in a closed path is 0. In a closed path is 0. What it means? It means that if you are applying a force on this particle and bringing it in this way back to its original position, such that the work done along this path is 0, then the force applied here is said to be conservative. Now we have to check this pressure force, because we have this work done which is equal to minus P into dV, Vi to Vf. So this pressure plays the role of a force here, so we call it pressure force. So we have to check this pressure force whether it is conservative or non-conservative. Okay. So for that we take a system such that we bring the system from initial point, initial condition, such that the initial conditions are, I can write the graph here. Suppose this is the volume and this is the pressure. Now suppose we are bringing this system from this initial condition to this final condition, such that here the volume is V1, here the volume is Vi, here the volume is Vf, here the pressure is Pi and here the pressure is Pf. So at this point A, I call it point A and I call it point D. So at point A, the initial conditions are Vi, Pi, and at point D, the initial final conditions are Vf, Pf. So in order to bring these systems from this point A initial condition Vi, Pi to this final condition Vf, Pf, we have different paths. So I consider two paths here. So let's suppose I call this point as point C and this point is point D. So I have to bring this system along two paths. One path is this one, okay, and one path is this one. So either I have to move this system through path 1, this is my path 1, this is my path 2. So here what I will do, I will calculate the work done in moving the system from point A to point 2 through path 1. Okay, I will calculate the work done through path 1. I will call it W1, and then I will calculate the work done in moving the system from point A to point B through path 2, and I will call it work W2, and then I will compare the two paths, and then I will compare the work done along these two paths. If the work done along path 1 is equal to work done along path 2, then we say that the pressure force will be conservative. If it is not equal to each other, then the pressure force will be non-conservative. Now for that I will consider the path number 1 first. So the work done along path 1 along path 1. Okay. Now path 1 is divided into two parts. One is from A to D and then from A to D. Yes, it is B, A, B. This is B basically, sorry, because T point is here. Now path 1 is divided into two paths. Path 1 is divided into two parts. One is from A to B and the other one is from B to D. So the work done along path 1 will be equal to the work done in moving the system from A to B. First I have to calculate the work done from A to B, and then we have to calculate the work from B to D, and then we have to sum both this work done and we will get the work done through path 1. Now if we are moving from A to B, volume remain constant, volume remain fixed, because at point A the volume is Vi, at point B the volume is Vi. So it means that the volume is fixed here. Now along B to D, volume changes from Vi to Vf, because at point B the volume is Vi, at point D the volume is Vf. So along path AB the volume is fixed, but the pressure changes. Fixed while the pressure changes. The pressure changes from Pi to Pf, because if you move from A to B, at point A the pressure was Pi, okay, and we are moving to B, so it changes to Pf. Now along path BD, the volume changes from Vi to Vf while pressure remain fixed. While pressure remain fixed, and which is Pf. Along this path the pressure is Pf. So the work done along path 1 will be equal to work done along path AB plus work done along path BD. Now along AB volume is fixed, so the volume is Vi, and initial volume is also Vi and the final volume is also Vi, and we have a negative sign because the work done is always equal to minus P into dV. Okay, so we have a negative sign here. So negative, the volume is fixed. Okay, and then we have P dV. Along path AB, so the work done will also be like this. So we have a negative sign here also, because we have a negative sign here. The work done, the volume is now changing from VI to VF. The pressure is fixed and the value of the pressure is PF, and we have this. Now along path AB, the volume does not change, so this term will be equal to 0, because dV, if I calculate, I will do it, minus P is const, P will be keeping outside because the integral is with respect to dV. So we have VI to VI dV minus PF is taking outside of this integral, so we have VI to VF dV. So here we have minus P into dV, which is V, and the integral is VI to VI minus PF, and we have this integral is dV, which is V, and we have VI to VF. Now this is equal to minus P, and the limits are VI minus VI, and we have minus PF, and the limits are VF minus VI. So this will give us 0. So the work done along path 1 is minus PF into VF minus VI. This is the work done along path 1, minus PF into VF minus VI. Now we will check the work done along path 2. So the work done along path 1 is, minus PF into VF minus VI. So you have to remember this one. Now along path 2, the work done along part 2 will be equal to, this part 2 is divided into two parts. One is AC and the one is CD. So we have to calculate the work done from A to C, and then we have to calculate the work done from C to D, and then after that we will add them and we will get the work done through part 2. So the work done through part 2 will be equal to work done in moving the system from A to C plus work done in moving the system from C to D. Now from A to C, along A to C, what will happen? Volume change. Okay, volume change from VI to VF, while pressure remain fixed. Pressure is fixed, which is PI. Now along CD, along path CD, volume is fixed, which is VF, while pressure changes from PI to PF. So work done along path 2 will be equal to, because work done is basically equal to minus integral of P into dV, where VI to VF, volume changes from VI to VF. Now work done along path AC will be equal to minus integral of, along AC the volume changes from VI to VF, while pressure is constant or fixed, its value is PI into D, plus, and then we have a negative sign here, so we have a negative sign here, and the work done from C to D, along C to D the volume is fixed, which is VF at both initial and final point, and the pressure changes while we have this dV. Now again, if this term will give us 0, so we have the work done along part 2, which is VI to VF, and we have PI into dV. Now PI is keeping outside with a negative sign, so we have dV VI to VF. So we have minus PI, and we have V into VI to VF. So we have W2, which is equal to minus PI into VF minus VI. This is equation number 2. So if I look at this equation, steric and this double steric, we see that from equation steric and double steric, steric and double steric, we see that the work done along path 1 is not equal to the work done along path 2, because here the pressure is final pressure, here the pressure is initial pressure, while this term is same. So it means that these two equations are not equal. If the work done along path 1 is not equal to the work done along path 2, then what it means? It means that pressure force is a non-conservative force. So this was all about conservation and non-conservative and non-conservative forces. Now I will stop my video here. In the next video I will calculate the work done for different systems.